let me share my screen, and now we are going to start. uh, like I want to give you one small tip about the spanning tree and rapid spanning tree. Okay, so let me start with the screen. Okay, Mukesh Singh, good evening, good evening. So this will be the topic, like this is mind map, and we are going to finish this mind map today. Yeah, but before we start this, okay, before we start this particular matter, I want to give you one live demonstration so you can able to understand the difference between spanning tree and rapid spanning tree, right? So first of all, I'm going to implement one packet tracer lab, and we'll test that how much time it is taking in the normal spanning tree, and then we will verify that what, like how much time I have to spend for the rapid spanning tree, right? So let me start this. So what I'm doing right now, I'm going to add three switches. Yeah, I'm going to add three switches. We can add two also. Let me add two. Okay, and now I'm going to connect them. Fast Ethernet 0 with fast Ethernet 0, and then fast Ethernet 2 with fast Ethernet 2, right? So now spanning tree will block one port. We know this. And now I'm going to connect computers. Okay. Okay. Now I can use any port. Okay. Now I want to verify using ping. So I have to assign IP addresses, right? This is required. So without IP address, I can't ping to each other. So I'm going to assign IP address, and it is like 192.168.0.1. Okay. So this is IP address of one PC, and I'm going to add second IP address, right? Okay. So this is IP address. Now I'm going to ping from PC 0 to PC 1, right? I'm going to ping from PC 0 to PC 1. So here I'm having this command prompt, and I'm going to ping 192.168.0.2. Yeah, I'm getting this ping, and I want continuous ping, so I'm going to use this DST. Yeah, like it is used to for the continuous ping, right? So yeah, it will, like my ping will be continue. And now what I'm doing, I'm going to remove this connection. Like I'm going to, Kesab is saying, good evening, sir. I'm still confusing. Does one switch have one MAC address, or every switch port interface have individual MAC address? Yeah. We can say that, let me give me 5 minutes. I'm going to answer your question. Okay. I'm going to answer your question. Okay. You will get, like, you will not be confused now onwards. Okay. So now let me, like, this ping is working, and now I'm going to remove this active line, right? We have this active line. This is like a blocking port. So I'm going to remove this active line, right? So I just want to find out that how much time it is taking. Yeah, how much time it is taking. So I'm going to remove this line, right? And now, yeah, we are getting this RTO, request time out. Now this line is not active, but it will be active. Yeah, it will be active. So I just want to find it out, like how much time it is taking, right? 1, 2, 3, 4, 5. Yeah, I just got 5 RTO, and now I'm able to communicate again. Yeah, so I got 5 connection request time out. Okay. So now tell me, like, which mode is the default mode? Which mode is the default mode? Which mode is the default mode? Any idea? Yeah, I'm connecting this again, and now let me wait. Okay, now one port will be blocked by spanning tree. It is automatic. Again, I'm getting this request time out. Okay, I'm getting this request time out because switch internally calculating the port, like BPDU communication is happening, and now finally there will be the one conclusion that the switch will block one port, right? So actually spanning tree algorithm is running on the switch right now. Again 5 RTO and I'm getting ping, right? So now what I'm going to change over here is in this particular switch, yeah, PVST is a default. Abhishek Sharma is saying we can say that PVST plus. Yeah, so here let me give a name like host name switch 1, and here we have another switch and it is like a CLI, and then enable config T host name, and here we have this switch 2, right? Yeah. So now what I'm going to change over here is I'm going to change spanning tree mode. Okay, I'm going to change spanning tree mode, like give command show spanning tree, and here you will get spanning tree enable and port like IEEE. It is like a standard, and in the Cisco switch we have like per VLAN spanning tree is default enable. Yeah. Good evening, Pankaj Bharadwaj. How is Indian Navy? So yeah, everything is fine. Everything is good. So now I'm going to configure, or I'm going to implement a spanning tree mode. Okay, spanning tree mode. And when you question mark over here, you will get PVST, and we have rapid PVST. Okay, so actually the default mode is like like we can say that it is a PVST plus, but here we can set like a rapid PVST. Okay, so we will get rapid, like it is called RSTP. Yeah, so it is RPVST, rapid per VLAN spanning tree, and you all guys know about PVST. I already explained you PVST. Why? Because this particular line will confuse you if you don't have any knowledge about PVST, and that's why I explained PVST in a previous session, and now we are doing this rapid PVST. It means per VLAN spanning tree with rapid. So it is like a rapid PVST, right? So enter. Now I'm going to on another, so like I'm on switch 1. Wait. Yeah, this is switch 1 and switch 2. Okay, and again I have to configure rapid spanning tree over here also. Yeah, so host like a spanning tree mode, and here I have to give rapid PVST. Okay, so my mode is now rapid. Okay, my mode is now rapid. So you can verify this by giving the command so spanning tree, and here we have this RSTP. Yeah, it is a rapid spanning tree. Okay, so spanning tree, and here we have RSTP, right? Now we are going to test this again. Okay, I'm going to this computer, and it is pinging, everything is normal, and here we have this block port. Yeah, here we have this block port. Okay, and this is what the active port is. Okay, so now I'm going to do same thing. I want to remove this particular link, yeah, this active link, and I want to verify that like how much time it is taking. Yeah, for span for normal spanning tree, IEEE spanning tree, we got 5 RTO, right? We got 5 request time out, and now we just convert our system from spanning tree to rapid spanning tree, right? So now I want to verify that like uh, how many RTO I will get, right? So let me remove this link. And before I going to remove this, like I want to ask you, like what do you expecting, guys? Like how many RTO I will get? Yeah, how many RTO I will get? Like request time out. Yeah, how many? Can anyone tell me? 1, 2, 3, 5, 6. Yeah, it is like a rapid, right? So it is working rapidly than the spanning tree. This is true. So if in the normal spanning tree I'm getting 5 RTO request time out, so here I will get less, like it will be less than 5, right? But can you give me any number? Yeah, can you give me any number? 1, 2, 3, 4. Yeah. How many? Abhishek Sharma is saying only one. Mark is saying one. Okay. Ryle is saying one. Nitish Sharma is saying good evening. Yeah, good evening, Nitish Sharma. Okay. So, Nitish Sharma, you just change your profile picture. So, like, I'm not able to identify you today. Okay. So, let me uh, remove this. Yeah. Okay. Not single one, but you guys are right. Like maybe in the production environment, you may lose like one ping and then it works. Yeah, it works. Maybe one, but there is a less chance for that. Okay. Now I'm going to connect this. You can use any port. So see this, what is happening over here. Okay, one port has been blocked by the RSTP. And now if you want to verify it again, yeah, we can. Like, let me remove this active port. Yeah, this is what we have, active port. Say this, like I'm going to remove this, and then I got like green. Yeah, immediate. Okay, so yeah, this is what rapid spanning tree is, right? Very quickly, and it works faster than spanning tree, right? So this is how it works. Now the matter is, we have to compare all the things. Like we have to compare all the things, and like what is the difference between all the variants of the spanning tree or all the variety of spanning tree. So for that, I'm having this mind map. Okay, I'm having this mind map. So first of all, we will compare STP with RSTP, and then we'll talk about PVST, PVST plus, and MST. Okay, and before that, before that, I'm going to answer one question about. See, here is the MAC address. Okay, here is the MAC address. So what is happening over here is switch having a MAC address. Yeah, switch having a MAC address. Switch don't have per port MAC address. Yeah, someone asked me this question. Yeah, so switch having a MAC address. Yeah, this is like a unique MAC address for the switch, but each switch of the port doesn't have any MAC address. Okay, and second thing is, I will explain you that why there is a MAC address for the switch for the next session. Like tomorrow, there will be the layer 3 switch. Yeah, so in this particular session, you can able to understand it properly. But right now, if you are saying that each port of the switch having MAC address, this is totally wrong, right? Okay. So now we have this STP, RSTP, PVST, and MSTP. This is like a 4 variety of spanning tree. And now I'm going to explain you, like I want to find out the difference between RSTP, spanning tree, and rapid spanning tree. Okay. So 6 differences are there that you have to understand. The first is the original spanning tree, and we also consider IEEE 802.1D. Okay. Now, when you are learning something, you keep this in mind. Okay. Sometimes Cisco is asking, like, what is how IEEE 802.1D implementation of spanning tree works? At that time, you just forget that, okay, IEEE 802.1D means STP. Okay, so you have to remember this IEEE specification also. Okay, now this is what RSTP, and it is like improved version of STP. Yeah, we got 5 RTO when we implemented this spanning tree, and using RSTP, switches per port MAC address, you can see it by command show MAC address table. Okay, Abhishek, we will talk about this later, because MAC address table and everything will be, we will cover tomorrow. There will be the session, and then you can able to understand all this point. Abhishek Sharma, we will talk about this for sure, right? So because right now I have to finish all this, and tomorrow be online, and I will, or will like communicate about this for sure, right? So here we have this original spanning tree, and here we have improved version of the spanning tree. Now, slow convergence, we got 5 RTO, it is slow, and here we have this fast convergence. So the first is STP having a slow convergence. RSTP having fast convergence, right? Second thing is port state. Yeah, port state. Now we already know about the port state. Yeah, we already know about the port state of a normal spanning tree. Like we already done this. Like we have this disable port. Now if the port is not participating in the spanning tree, port is like shutdown mode, we call it disable. Then it is like a blocking. Okay, so if spanning tree is not considering this port as a root port or a designated port, we called it a block port, right? And then when you start the port, it has a learning state, it has a listening, learning, and forwarding state. Yeah, so let me give you this example, like how we are getting this. Okay, as well as switch as a base MAC address as well. Yeah, so this is what the, like, this is the topic of spanning tree. Now we are talking about MAC address. So that's why I'm saying you will talk about tomorrow for sure. Yeah, because this will be the topic of tomorrow. L2, L3 MAC address table. We will talk about everything. Okay. So now see what I'm doing. Like I'm having this switch. Yeah, I'm having one switch. Now, when you connect any computer with the switch, okay, when you connect any computer with switch, I'm going to just connect them. Okay, I just connected with the port number 7. Yeah? I just connected with the port number 7, and now I'm going to give this command, so spanning tree, and here you will get this. See, yeah, this is what the rapid spanning tree right now. So let me convert this like a spanning tree PVST mode. I have to change this mode right now because it is a rapid mode, right? So I'm going to change this. Now I'm going to connect computers again. Okay, this is okay, and now see, this is it is green, and it will, like, it is orange, and it will take time. Okay, so I'm going to switch one, and here you will get this. See, here we have this port number 15, and it is LSN. Okay, so the port is in a listening state right now. The port is in the listening state right now. Okay, so how much time it will take, when the port is in the listening, like it is in the listening mode, it will take 15 seconds. Yeah, because this is what the forward delay timer. Okay, so after 15 seconds your port will be in the learning state. Okay, so after 15 seconds your port will be in the learning state. So right now it is in a forwarding state because when I explain you, this passed away. So when you connect any port, the first is like a disable, then this port will be in a listening mode, it will take 15 seconds, and then it will be in the learning mode. Now learning mode will take 15 seconds. So after 30 seconds my port will be up, right? So let me connect one computer again. Yeah, I'm going to connect this. Yeah, so spanning tree, see here we have this listening. It is like based on forward delay timer. Yeah, like by default forward delay timer is a 15 second. So it is a 15 second for listening, 15 second for learning. Yeah, you can change this timer as well. Okay, but by default it is 15 and 15. Now it is a learning. It will stay for the in a learning mode for 15 seconds, and then after 15 seconds the port will be on the forwarding state, right? So whenever you connect any port with the switch, like switch has to determine that the another switch is connecting, or maybe you are connecting end device. Okay, so there will be the spanning tree calculation, like algorithm is running on, and that's why you have to wait for 30 seconds. Okay, now if you are connecting endpoint, like if you are connecting computers directly, there is no need to use this learning and listening mode. Okay, so we can bypass this, and this is what we call port fast. So we'll talk about this port fast tomorrow. Right now, basic thing is, in the switch we have this learning, like on in the normal spanning tree we have this learning mode and listening mode, and it is taking 15 total 13 second my port to be up, right? The first thing about the spanning tree. Okay, now let me explain you all this system so you can able to understand the why spanning tree is taking more time than the rapid spanning tree. Okay, so let me draw one lab over here. Okay, the first matter is like I'm having 5 switches. Okay, it is connected. Okay, it is connected. Now we are assuming that this port is in block port. What if we enable port fast on the port connecting to another switch? Okay, so port fast is a topic for tomorrow, Abhishek. Actually, if you give me some time, so I can cover all these points. Yeah, and once I will finish all this point, it will be like tomorrow we will talk about this. Like there will be the special session for port pass, BPDU guard, and everything. Yeah, so it will be good if you ask me relevant question right now, because what will happen, like if I will turn on this particular way, I cannot able to spinning complete this spanning tree. So your question is really valid, but right now, if you can wait for one day, yeah, we'll definitely talk about this. Okay, so here, like this is like a block port. Okay, now in the spanning tree, suppose this is like a root. Yeah, this is like a root. So root is sending BPDU. Okay, in the normal spanning tree, root is the BPDU, like root is sending BPDU. Okay, now what happened if this link between, like let me give name A, B, C, D, and E. Now the link between C and E goes down. Okay, now link between C and E goes down. Okay, so what happened? E will not get BPDU. E will not get BPDU from A, right? A will, like E, this switch E will not get BPDU from A. Now if it is not getting BPDU from switch A, it has to wait. Now by default, the timer for the BPDU is like a 2 second. Yeah, we have this 2 second. Okay, and max edge timer is 20 second. Okay, so what is happening over here, if E is not getting BPDU from A because this link is down, C, like E will wait for 20 second. Yeah, because 20 second is a default max edge timer. Yeah, 20 second is a max edge timer. So it will wait for 20 second, then it will send one TCN BPDU, then the root will, like topology chain notification and all this happens, and at the end spanning tree will open this particular port. Okay, spanning tree will open this particular port. Now when the spanning tree will open this particular port, okay, again it is having like a listening mode and it is like a learning mode, so it will take 15 plus 15 more minutes. Okay, so it will be like a 30 second, sorry, not minutes, it is a second, extremely sorry, it is a 30 second, right? So what happened, first of all, E is not getting BPDU from the root, so E waited for the 20 second. Now it is confirmed that link is down, so E has to open this particular port. Okay, so this port will be converted to the root port, but again when this port will be activated, it will take 15 plus 15 second. As I told you, the first is like a listening mode and second is like a learning mode, so the total would be 30 plus 20, so it is like a 50 second. Okay, this is what the 50 second timer. So why we got this 5 RTO, because it is taking like a 50 second maximum time. Okay, now sometime is happening like the link is directly connected with the root. Yeah, for example, link is directly connected with root. Now, if link is directly connected with the root and this particular link goes down, root will not wait for any TCN, BPDU and anything. Okay. So in this case, this particular port can be opened directly because root knows that this link goes down. So in this case, this E will not wait for the 20 second, and then I will get the result within a 15 plus 15 second. So it is like a 30 second. So if the link which is connected directly with the root goes down, it will take 30 seconds to communication establish again. This port will be up within a 30 second. If link is not directly connected with root, yeah, we have to wait till this 20 second plus then 15 plus 15. So it will be 30. So total would be 50 second. Okay. So the minimum timer is 30 second and maximum timer is 50 second for spanning tree. It is, I'm talking about IEEE 802.1D, right? So now, if you have any question about spanning tree, you can ask me now, right? Like this is what the spanning tree timer works. Okay, spanning tree timer works. Is it clear? If it is clear, just type clear. Yeah. No more question answer today. It is like a very straight topic. Yeah, and I'm teaching you, this is like first time. So there is like no need to ask more question about this. But if this point of your concept of spanning tree is clear, just type clear. Yeah. Yeah. Ryle says clear. Okay. Yeah, I want one or two more clear. Yeah, Mark is saying clear. Super. Okay. So in the spanning tree, we have this disable, blocking, listening, learning, and forwarding. Okay, now listening and learning mode is totally based on this timer. Okay, it's totally based on this timer and it is called forward delay. Now this concept is also clear, like hello timer is 2 seconds, max edge timer is a 20 second, and forward delay is 15 seconds, right? So this is how it works. Now and when we talk about the port state of a rapid spanning tree, it has discarding role. Yeah, it has a discarding role. Now discarding is like it is a mix of disable, blocking, and listening. Yeah, it will like everything is in the one status and it is called discarding state, right? So if your port is in a blocking, you will get the status like discarding. Okay. Second thing is we have this learning mode, same as in the spanning tree. And third is like a forwarding. You know about this forwarding as well. Okay. So this is what the three state. Here we have one fourth test also, which is known as alternate. Yeah, which is known as alternate port state. Yeah, so we can add like this. Yeah, this is alternate port state. Okay, so we can use this also. Okay, now this is what the fourth port, right? A fourth state. So the thing over here is we don't have this listening mode, and whenever you connect your computer, it will directly start with the forwarding state. So it will not take time. Okay, so we can say that here we will get this 30 second will be no there. Okay, 30 second is not there when we are using this rapid spanning tree, right? For example, if I'm going to convert this, okay, if I'm going to convert this into the rapid spanning tree, okay, and now okay, and this is what the port number 17. Yeah, and here we have this, yeah, in the forwarding state directly. Okay, so the first thing is we don't have this learning, listening, and all this more in the rapid spanning tree. Second thing is there is no max age timer. Yeah, there is no max age timer in the spanning tree. Now, like if you want to just find out like how this spanning tree works, right? Like why there is no max age timer and why normal spanning tree is using max age timer, right? So here is like a wait. This is what like a root port designated and blocking. Here we have this root port role is like a root designated. Yeah, I just added alternate over here. Okay, so wait, I'm going to delete this. Yeah, see, we have root port, we have designated port, and we have this alternate and backup port. Yeah, here we have this root port, designated port, and blocking port. If your port is having a lowest cost with the root, it is called root port. Same concept over here, it is a root port. If you have root, the root port having a port status is like a designated. Here we have same designated port. Here we have this blocking port only, but here we have this alternate and backup port. Yeah, we have this alternate and backup port. So I will explain you alternate and backup port. Like just give me some minute, I will explain you all this, right? Now, see, convergence. This is what like hello 2 second, max edge 20 second, forward delay is a 15 second in the spanning tree. But here we have this proposal and agreement process for the synchronization, and it is like a less than 1 second. Yeah, it is less than 1 second. So this is what you have to understand. Okay, this is what you have to understand. The matter over here in the spanning tree is let me go to the whiteboard. See, for example, you are using spanning tree. Yeah, it has like situation is like right now what happened in this normal spanning tree. I'm talking about IEEE 802.1d. Yeah, this is root. Okay, so in the normal spanning tree, this is root, and this particular root is sending BPDU. Yeah, it is sending BPDU to each and every switch. Okay, each and every switch. So in the normal spanning tree, root is the responsible for sending BPDU, and all this switch is waiting for the BPDU from the switch. Now, like based on the diameter, like how many switch are there in between your non-root switch and root switch. Yeah, so Cisco defined this 20-second timer. Yeah, and we call it max edge timer. Yeah, because we have to wait BPDU which is coming from the root. Yeah, so we don't know the diameter, like how many switch are there in line, right? So there is a timer, and which is like a 20-second. If you have a less diameter, like if you have 2 or 3 switch, you can decrease the time as well. But Cisco is using this default timer, and because we are using this, we did this practical using the default time. I calculated this. We have to wait for this 20-second plus 30 seconds, so it is like a 50-second, right? But when you are using rapid spanning tree, okay, it has a proposal and agreement for synchronization. So what happened over here? Yeah, all the switch can able to send BPDU. Okay, all the switch can able to send the BPDU. So here is what happened. Like there is a proposal agreement between these two switch, so they can able to communicate like via BPDU. This can be able to communicate via BPDU. Now this switch will send the BPDU to this particular switch, and this port switch will able to send the BPDU to this switch. So there will be the proposal and agreement. Now what happened? Like suppose if this port goes down, they do not need to wait for this hold down timer or anything. Yeah, so there is no waiting, because you do not need to wait. You do not need to wait for the BPDU you are getting from the root. Yeah, so there is no max edge timer. Yeah, if you are not, like this link is down, it means you are not getting BPDU from your upstream switch, and you can detect the failure directly. Okay, so because the switch in the rapid spanning tree, we have this proportional and agreement, we do not need to worry about all this timer. Yeah, like max edge timer and forward delay is not there, and the convergence is less than 1 second. And because the convergence is really very low, we are getting ping within a second. Like we can lose only one ping, and then we are able to start the communication, right? So this is like a sixth. The switch that discover the changes in the network inform the route. Yeah, inform the route. So every communication in the spanning tree is from known route to route. If I'm having any problem, I will inform route, right? So route by sending TCN, and route inform all other switches. This is what the normal spanning tree. And I already explained you about the timer. Like it will take 20, like 30 second, and then the total is like a 50 second, right? And here the TC is flooded throughout the network. Every breeze, or we can say switch, generates topology changes and inform its neighbor when it is aware about the topology changes. So every switch can able to generate TCN, and here we have to wait for the route, right? And here we have to count that, like what is the diameter from known route switch to switch, and that's why they have lengthy dipole timer also. Okay, so that's why it is taking too much time. Yeah, it is taking too much time. So better you can go with the RSTP, and RSTP is compatible with STP. So if you have older switch and you connect this with the RSTP, it works like a STP. Okay, now let me talk about this alternate and backup mode. See, in the spanning tree we have this port role, and we have this blocking, and here we have this alternate and backup. Okay, alternate and backup. So let me go and let me create one topology so you can able to understand this properly. Okay, so I just going to explain you this port state, right? Wait. One with one, two with two, and three with three. Okay, yeah, Nitish Sharma, RSDB is upgradation of STP. We can say this. Okay, now this is the default mode. Default mode is RSTP with PVST. Okay, so default mode is STP with PVST. Yeah, it is taking time, and finally we will get this block port and all, right? Yeah, this port has been blocked. So let me change the scenario so you can able to understand properly. Yeah. Okay, and you all know this, what is the algorithm and everything, right? You all know this, like how they selected the route. This is what the designated port, this is like a route port. I already explained you all this, right? So now this port is in the blocking state. Right now I'm going to verify this. Yeah, this is what we have switch. Okay, and so spanning tree, and here we have this blocking, and here we have this alternate, right? So the mode is by IEEE. Okay, now CLI, and I'm going to change spanning tree mode rapids PVST. Okay, if you are using spanning tree, or if you are using a rapid spanning tree, okay, the matter is there is a convergence time difference the way it works. For example, spanning tree is getting BPDU from the root. Rapid spanning tree have this agreement and proposal system, so you will get better performance and the convergence time is low, right? But the way spanning tree elect the root is the same as rapid spanning tree. Yeah, there is only main difference is the convergence time, and here we have this port, like we called it a blocking port, but here we have this alternate and backup. Okay, so now I'm going to this switch. Yeah, we called it alternate. Now if I'm having one another port, yeah, if I'm having one another port which is eligible to become blocked, okay, it is eligible to become blocked, it will be backup. Okay, it will be backup. So if you have two ports, okay, that is like eligible to become blocked, the first one is considered as an alternate and the second one will be considered as a backup. So if the port there, like you must have a second port. Yeah, so we called it as a backup, right? So let me do this, like let me try this. Okay, if we have like a hub, it would be better, but I think in the GN, like in the here we don't have hub, right? So let me connect them, but it will be on the different spanning tree. Wait. Yeah, I'm going to connect one again port and it will block one more port, right? Hub would be better option over here because it will block same port from the same switch. Because if I'm using switch over here, it may block the port of this particular switch. Actually, what I want to block this port of that particular switch too. Okay, so one port will be like alternate and one port will be backup. No, see, this is like a blocking this particular port. No, we have to connect hub. So let me tell you this, because we cannot able to add this hub over here, right? So what I'm trying to explain you is, if you are connecting switch, it will be like a problem. Yeah, so here we have this block port. See, for example, I am having three switch. Okay, this is one, this is one, and this is one. So I can say this switch 1, switch 2, and switch 3. Okay, and now we connected this 3. Now what happened, like spanning tree will calculate one port as a block, right? So this is like a block. In the rapid spanning tree, it is alternate. Okay, it is alternate. Now if you connect hub with this particular switch, why? Because I want that the port to be block of this particular switch. Now hub is like a passive device, so hub cannot block the port. So what happened here, the spanning tree of this S3 will block one another port. Yeah, it will block one another port. So now this switch having two block port, this and that particular port. Okay, if this is the condition, like if this is the condition, this switch having two block port. Okay, so the first is considered as an alternate and the second is considered as a backup, right? But this port must be from the same switch, right? So if you want to understand it practically, you have to connect hub. So what happened, it will block the port from the same port, and then you will get this result, like this is what the alternate and this is what the backup port, right? But the thing is, you must connect, like the port must be from the same switch. Here what happened over here is, like, see this, here it is like this is a one block port, so it will not create loop over here, and we got one another port here, like it will not give us a result. Yeah, so we have to connect hub, and I think so, like I'm not the big user of this packet tracer, so yeah, we are not able to get this hub over here, right? So because of this, we cannot able to find it out, this backup port. But if you understand the topic, like see this, yeah, the same port, yeah, same port, it is like a one is alternate and one is called backup, right? So this is what the rapid spanning tree. And now I'm going to move towards the third point, and what we call it is a PVST and PVST plus. Okay, so if this point is clear, like STP and RSTP, yeah, just type clear so I can go ahead. Yeah, RSTP is upgradation of STP. Yes, Nitish Sharma, it is right. Yeah, is it complete? Now they're asking less question about RSTP and STP, but in the older exam, this was like RSTP is really useful topic. Okay, so yeah, is it clear, guys? Yeah, waiting for your reply. Okay, Mark is saying clear. So let me go ahead. Now we have this PVST. Okay. So what is the PVST? It can be STP or it can be RSTP, right? When we're talking about PVST, it is like a per VLAN and it can be STP and it can be RSTP. So if you are using PVST, it is with the rapid mode, we call it rapid PVST, right? We call it rapid PVST. Okay. Now the matter over here is, if you are going to use, okay, in the network, root switch will be selected automatically or we can use manually. Nikhil, I already explained you this in the previous session. Okay, like you can select manually by using this priority command. You can give the priority, less priority to the switch, or if you are not going to select any like manually, the switch with the lowest breeze ID will become the root. Yeah, so it is like a two option. By default, switch select root automatically, and if you want to select your own route, you can also do this. Yeah, so in the PVST, like there are, this is like question like PVST and PVST plus. So there are lots of people they're asking like what is the difference between PVST and PVST plus, right? So let me, PVST and PVST plus are Cisco proprietary implementation of STP. Okay, and PVST supports ISL. Okay, so PVST basically supports ISL encapsulation, and PVST plus, yeah, PVST plus will send 802.1D BPDU, making PVST plus compatible with IEEE STP. Yeah, so actually here I can say that, yeah, PVST is a Cisco proprietary implementation of STP, support ISL encapsulation. Yeah, so it is not compatible with, we can say that, with the encapsulation like other STP encapsulation. Like here we are using this PVST plus will send 802.1D standard BPDU, making PVST plus compatible with IEEE STP. Yeah, so this is what the changes. Okay, so PVST is not compatible with other, PVST plus is compatible, and basically we are using PVST plus. Okay, second thing is, the advantage of PVST is allow a spanning tree to be optimized for the traffic for each VLAN. Yeah, it is basically used to optimize traffic for each VLAN. So let me give you one example, because in this, based on this example, we are going to explain about like MSTP. Okay, so the first thing here is, suppose I'm having 3 switch. Okay, now all these 3 switch, yeah, all these 3 switch is connected and the spanning tree is there. And let me assume that we are having 2 VLAN. Okay, we are having 2 VLANs. Okay, so what happened over here, if we are talking about normal spanning tree, IEEE basic spanning tree, it will block any one of the port for both VLAN. So it will be like this particular port has been blocked for VLAN 1 and VLAN 2. So this port is now blocked for VLAN 1 and 2. So whatever the traffic will be there, it will be passed through that particular link. Yeah, it will pass through that particular link. And this basic link is like non-used. Yeah, it is a non-used. But if you are using a PVST, what happened over here is you can define different route for each VLAN. So I can say that this particular switch is a like switch A is a root. Yeah, switch A is a root for VLAN 1. Now, if this particular switch is a root for VLAN 1, yeah, this switch is a root for VLAN 1, it will block this port for VLAN 1. So this particular port is blocked for VLAN 1 because this is a root. So this particular port is blocked for VLAN 1. And this switch is a root for VLAN 2. So if this switch is a root for VLAN 2, okay, this port is blocked for VLAN 2. So now what is happening over here, we have different block port for a different VLAN, and we can configure it by utilizing the root placement. Okay, so in this case we have to define root manually, like we have to configure that this switch can be a root for VLAN 1 and this switch 2 can be root for VLAN 2. Yeah, and how we can do this is like I explained you in the previous section also. Now if you identify this over here, we have two blocking port virtually, and if you find it out that both the port is open also. For example, if I'm having PC in a VLAN 2, if it is sending the data, it will go through over this port. Why? Because this is blocked for VLAN 2. Yeah, this is port blocked for VLAN 2, so it will go through this particular. Now if I'm having a data for VLAN 1, like this is PC is in VLAN 1, it will go through this particular port because this port is blocked for a VLAN 1, right? So by utilizing the spanning tree root placement, we can able to block port per VLAN, and you can add rapid also here, so it will be like rapid spanning tree, right? But this is what the question, like last time I got this question and I told them I will explain you later. Okay, I explain you, I told like I will explain you later. So this is the time I am explaining you. Okay, wait. For example, same system, wait, let me draw in the reverse order so you can able to understand properly. Yeah, now I am asking you question, like we have 50 VLANs. Yeah, we have 50 VLANs. Now tell me how many port I can block. Yeah, like in this situation, like we have 3 switch, and the situation is like we have 50 VLANs. Yeah, we have 50 VLANs in this particular switches. Okay, so now tell me how many ports I can block. Yeah, 1, 2, 3, 4. Yeah, can you tell me like how many ports I can block? Yeah, I'm having 50 VLANs. So the question is like how many port I can block? Nitish Sharma is saying 2, right? This is what the absolutely right, because you are having 2 ports, like there is only 2 way, so you can block 2 port, right? You can block 2 ports. So what happened if you have Mark saying 6, but Mark, we have only 2 ports. Like see, if you have 50 computers over here, okay, like 50 computers, each of in a different VLAN, Okay, each of the port is in a different VLAN. How can I block all 6 port? Understand this? Yeah. Ryle is saying 1, but there will be 2 because we have 2 path. Yeah, 2 paths. So we can block 2 path because we are already having like all these 50 computers are there. Okay, and each of the computers is a different VLAN. So each one is sending the data. So we can block only 2. Right? Mohammed Sahed is saying right like 2. So if you are using PVST over here, okay, your switch will run the algorithm for 50 spanning tree. Okay, 50 spanning tree. There is BPDU for each and every VLAN, and at the end, you will get only 2 block port for sure. Okay, so after running 50 instance of spanning tree, you will get 2 block port. Now in this case, what happened? It will be like for that, like if you want to use this, we have to use like this. For 1 to 24, I'm going to block this port. For 1 to 24, I'm going to block this port because this is root for 1 to 24. Yeah, this is root. So it will block that particular port, right? And for 25 to 50, this will be root and it will block this particular port. Yeah. So after running 50 instance of spanning tree, you will get 2 block port for sure. Yeah. So this is what, like, it will generate traffic and all this. Yeah, it is in LAN, it is okay. If you are using like this, it is okay. But it doesn't make any sense because ultimately what we are getting is like a 2 block port, right? So in this particular condition, like if you have more numbers of VLAN, okay, 50 instance of spanning tree will be like it will consume traffic and all this. It will also use the resources of the switch. Okay, the second option is you can go for MSTP. Okay, the full form of the MSTP is a multiple spanning tree. Okay, now here maps multiple VLAN into the same spanning tree instance. It supports up to 6 instances of RSTP. Okay, and then the CPU and memory requirement is less than the rapid PVST plus, but more than RSTP. Like it is required more than RSTP, but the less than the rapid PVST. For one instance, block 1 port. How can I do this? Like we have only 2 port. Yeah, so how can I block 1 port per instance? Okay, so here the system is like this. See, I can't delete this. Why? Here we have system is like this. Instead of, yes, this command is okay. Yeah, the system is maybe you cannot use this word range. Wait, I have to verify this. Yeah, VLAN range. Okay, so you just need to give command like a 3, like 1-25. Okay, so you do not need to use this word spanning tree range. Okay, you can use like spanning tree VLAN 1-25. Yeah. Okay, so this word range is not required here. Okay, so what happened in the MST? Okay, MST will block 2 port only. Yeah, because we have a possibility of 2 ports. We cannot block more than 2 port for sure. But instead of running 50 spanning tree instance, what we can do, we can combine same VLANs into the one instance. So we will create one instance for this VLAN, So like we have instance 1. Yeah, we have instance 1, for 1 to 24, and we have instance 2 for 25 to 50. Okay, so ultimately if we have two instance, it will block two port. Yeah, if we have two instance, it will block two port, and there will be the two instance of spanning tree will only run, right? So if you are using if you are using PVST over here, the result will be two block port by running 50 spanning tree instance. And if you are combining this VLANs into the instance and running MSTP, you will get same two port blocked. Yeah, you will get same block port 2. And the advantage is you have to run only two spanning tree instance. Okay, so this is what the advantage of MSTP. So if you have less number of port and number of VLAN instance is very high, you can go with the MSTP. Yeah, so in our exam they ask you, but this is not practically available in the like we cannot do it practically right now. Okay, so this is what the 4 variant, main variant, and here we can use PVST with rapid, so it will be like rapid PVST plus, right? So this is what done about STP, RSTP, PVST, and MSTP. Okay.